Today we are going to create a container in Linux using a kernel feature called Namespaces. Let us start by creating a disk image of 2 GB using dd command, which will be used to create a container in it. Then format the disk image as btree file system. Here you can observe the created file system size is 2 GB. Mount the new disk image in btrfs directory, which is created under the root directory. If we execute the fdisk or lsblk command, we can notice that a new block device or a virtual disk loop 0 created. Now let us extract the content of Alpine image using docker command to the directory /btrfs/images/alpine. Here we are using docker command just to extract the content of Alpine image. Create a subvolume Alpine under the directory /btrfs/containers, which will be used to hold the Alpine container root file system. Then copy the extracted Alpine image content to the subvolume created. Now let us create the container using namespaces. We use the unshare command to create new namespaces, mount, uts, ipc, net and pid, and run bash init. We also pass in the fork flag to create a new process as a child of the unshare command, which would hold PID1 inside the container. It may seem like nothing happened from the command output, but we have created a container environment using namespaces and isolated it from the global namespace. You can observe that the new bash process running inside the container has a PID 17325 in global PROC file system, but when we mount the PROC file system of the container, the same process has the PID 1. The first mount command prevents any mounts that the container make from being visible to the global mount namespace, and vice versa. Still, the container environment is not completely isolated as it has access to the global root file system. Next step is to make the file system of the Alpine image as the root file system of the container, so that the container is fully isolated and confined to the Alpine file system. It can be achieved by using pivot_root command. Since pivot_root command expect new root directory to be right under the global root directory, we created a bind mount/alpine under global root directory, which points to the Alpine file system. Once the command has been executed, we can observe the /alpine directory has become the root directory and is detached from the global root directory of the container. Now, when we list the content of root directory in second terminal, you can see it is different from that of first terminal where container is running. Also, Alpine directory in global namespace shows no content inside it, though it has become the root directory inside the container and contains Alpine file system. Which shows, mount points created inside container are not visible outside the container environment. We know the container we created is running bash inside it, but it does not belong to the Alpine image. So, the final step is the replace bash with the process to be run inside the container. Alpine contains only two commands, shell and apk. Now let us replace the bash process with shell that comes with the Alpine image, which is expected to be run inside the container. That's it, we created the Alpine container and running shell in it. We can change the host name inside the container to Alpine without affecting the name of the host running the container. In the second terminal, we can notice that the host name remains unchanged in global namespace. In this video, we covered only the namespaces part and created the container. The kernel features control groups and capabilities can be used to restrict the resource utilization and capabilities of the container. Hope that helped you. Thank you.